Okay, this video is going over 3D figures in geometry. We're first going to talk about some of the vocab you need to know. For geometry of solids, the first word you're going to need to know is polyhedron. That is the solid formed by polygons that encloses a single region of space. Okay, now that's what you think of when you hear 3D figure. Okay, and most commonly we're just going to say the 3D figures or the 3D shapes. Okay, but that's the proper term. Okay, these polyhedrons have parts to them: faces, edges, and vertices. Okay, a face is the flat surfaces of the polyhedron, so the actual polygons that are making it up. In this example down here, there's 5 faces because you have the 4 sides, okay, of this pyramid, so 4 triangles, and then the base down here, this is this rectangle, so a total of 5 faces. Okay, the edges, okay, those are the segments where 2 faces meet. Okay, and I've highlighted them here in red. So there's 1, 2, 3, 4, 5, 6, 7, 8 edges in this specific example. Okay, and then the vertices are the points of intersection where 3 or more faces meet. Okay, so this right here is a vertex, and then in each of these corners is a vertex. So there are a total of 5 vertices. Now we're going to talk a little bit more specifically about certain types of polyhedrons, prisms and pyramids. Okay, so you can see the definitions here if you get these copied down. A prism is a 3D figure with 2 bases, okay, and those 2 bases are parallel congruent polygons. So they're going to be exactly the same, and they're going to be parallel to each other. Okay, and they're connected by parallelogram faces. So the faces, okay, that are not considered the bases, those are also called lateral faces. And we'll look at an example here in a second. Okay, so 2 congruent parallel bases connected by parallelograms. Okay, if it is a right prism, okay, that means that those parallelogram faces are actually rectangles. They're rectangular faces. That means they have a right angle. That's why it's called a right prism. Okay, and so all of the, what you would probably think of as the sides, are going to be rectangles. Okay, and that distance from base to base, the length of that rectangle, is going to be the height or altitude of your prism. Okay, a pyramid, on the other hand, is a 3D figure with only 1 base, and that's the example we were looking at just a second ago. Okay, that was a pyramid. There's 1 base, and all of those lateral sides or lateral faces meet at 1 common vertex. Okay, and all of those faces are going to be triangular. Okay, the base of the pyramid can be any shape. It can be a triangle, rectangle, trapezoid. Okay, you can get into hexagons or pentagons, octagons. Alright, so here's some pictures as examples to show you the difference in prisms and pyramids. Okay, a prism has 2 bases, and I've highlighted those here in red, that are congruent and parallel to each other. So in this one on the left, both of these are rectangular and they are parallel to each other. These 2 that are highlighted in red are never going to intersect. Okay, if those are your bases, okay, they are rectangles, you would call this a rectangular prism because we name our polyhedrons based on the shape of the base. So this is a rectangular prism. Okay, the one on the right, the 2 bases that are congruent and parallel, are triangles. So this would be a triangular prism. Okay, and if you were to be told that these are right angles, which they are, but they weren't marked, if they were marked, or you were told in the instructions that they were right, you would say this is a right triangular prism. Okay, now your pyramids have only 1 base, and it can be any shape. This one on the left has a rectangular base, or a square base, if it was marked that these are all congruent sides, and these are 90-degree angles. So this would be called a square pyramid, because it's a square base, or a rectangular pyramid, if you didn't know that it was a square. Okay, this base is a triangle. Okay, so this would be a triangular pyramid. Okay, now the one up here that we called a rectangular prism, if you were told that these were squares and that the connecting them were all congruent squares, all 6 faces, then you could also call this a cube. Okay, but that's only if they're all 6 sides are a square, like a dice. Or a die, I should say. Okay, now we're going to get into some other 3D figures that are rounded and you use circles. And that first one is a sphere. Okay, a sphere is a set of all points in space at a given distance from a given point. Down here is an example. This would be the center of your sphere, okay, and any point at a given distance, which is your radius, in any direction. Okay, if I go any direction in the same distance and use all of those points, that's what makes up the sphere. Okay, there are no edges, no vertices, no faces, it's just a sphere. Okay, in a cylinder, you have 2 circle bases connected by a segment called the axis. So here, and I've made a note that in a right cylinder, the axis is the height. So this example drawn here, this is a 90-degree angle, so this is a right cylinder, and this right here that's labeled H for the height, this is called the axis. Okay, and then of course you have your radius of your circle, okay, which would be the same because the bases, just like in a prism, the bases are congruent and parallel. They're just not polygons, they're circles. Okay, you see cylinders all the time in the real world. Your cans of soda or, you know, cans of soup, anything like that. A lot of piping and different things like that. Cone is the last one we're going to talk about, and it has one base that's a circle and one vertex. Okay, the only vertex is right here at the tip top, and your base, your single base like a pyramid, but it's not a polygon, it's a circle. And this also is a right cone, okay, because this right here makes a 90-degree angle with the radius. So this would be considered the height or the altitude, and this would be the radius of your cone. That's all we're going to discuss for now. Check out the next few videos, which will go into more detail about working problems with surface area and volume of these different 3D figures.